when you fully understand what SLI, SLO, and SLAs are. If you missed our video on site reliability engineering, check it out first. So everyone is struggling to deploy software to production, mainly because of competing priorities between operation teams and development teams. Operation teams want to make sure the system is up and running, reliable, while development teams need to bring new features and capability. The wall between the teams often create massive conflicts and slow down your release cycle. That's why Site Reliability Engineering leveraged the concept of service level indicators and service level objectives to address this challenge. Often developers don't realize or even agree that reliability is an issue. It is a very common DevSecOps problem across industries, all the way back to Google starting in the early 2000s. To get started at solving this issue, you must focus on a few critical concepts. So let's take a look at some of the key foundation you must define to be able to really set in place proper site reliability engineering model. First, you must define what availability means for your organization. You must define the proper level of availability per projects. And finally, you must define the disaster recovery process and planning for failures. So let's take a look at availability and finally understand the nines, the famous 99.999 uptimes and so on. Although 100% availability might be your goal, it is unreasonable to expect your service to be available every minute of every day throughout the year. Maintenance, upgrades, or just unforeseen events, acts of God, make it impossible for a provider to guarantee 100% uptime. Just so you realize, 5 nines, which is 99.999% availability, means you will only see 9 minutes and 15 seconds of downtime per year. That's right, per year. Most can't do that. If you compare to 4 nines, which is 99.99%, you will be able to have 52 minutes and 36 seconds of downtime per year. 3 nines is 8 hours and 46 minutes per year. Most organizations will struggle to get anywhere close to this number. So first, let's take a look at what service level indicators really are. SLIs are numerical indicators defined by your organization, often with your product team, your SRE team, and your product owners, such as latency, throughput, and failures per request. It usually informs of the health of a service. An example could be your latency of your request or your ratio or errors to total requests. So now that you define SLIs, you want to tie this back now to service level objectives, SLOs. Let's take a look. So SLOs are an agreement between all of your stakeholders to define how reliable your services should be, based really on your SLIs and those indicators, and agree upon bounds for how often those must be met, usually per year. As discussed, 100% uptime is expensive and very complex. Leading companies aim for 5 nines, which is already incredible. By giving that flexibility, you need to understand you also enable you to fail. If you are committed to a very high uptime, it will be very difficult to have room for innovation, which means you will be stale, get behind, and more irrelevant. You're not going to be able to compete. So this gives you the ability and flexibility to have operational failures and some failure due to new feature deployment. Some of the SLO example would be a ratio of error to total requests received in the past 10 minutes to be less than 0.1%. Or a 99 percentile latency of requests received in the past 10 minutes to be less than 200 milliseconds. So now that you have SLIs with clearly defined indicators, and you have SLOs, clearly defined objectives for these indicators with a yearly target, now you can set in stone what we call your service level agreements. These agreements are between your organization and your customers. This is the first service level discussion that's involving external teams. Your SLIs and SLOs are only designed for within your organization. Your SLAs are agreements between your customers and the organization based on your SLOs, but usually pad them to give more flexibility and leniency than your internal SLOs to leave room for errors. It gives an expectation of your service level and, more importantly, the ramification if the team does not meet those promises. So if you fail at achieving the SLA that you gave your customer, and what would that entail? Maybe remediation, free credit, refunds, and things like that. Some example could be your customer is compensated if the 99th percentile of latency of requests received in the past 10 minutes is more than 400 milliseconds. Often you're going to find these to be on a yearly basis. So now that we understand what an indicator is, what is an objective, and now an agreement with your customer, we have the picture of SLIs, SLO, and SLAs. Let's dig deeper. An SLI becomes SLO by combining the SLIs over a period of time, such as a year, to compare to your targeted yearly uptime. SLIs are metrics over time that informs the team about the health of your service. SLOs are objectives based on SLI scaled over a period of time, usually a year. And SLAs are agreements that are based on SLOs but padded with your customers to define expectations and ramification if the service does not meet those SLAs. This is back to the foundation of DevSecOps principles and leveraging proper metrics with a common language to track the organization availability. Many organizations make the mistake of thinking of SLOs as a bare minimum threshold to achieve, but SLOs should be seen as both lower and upper bounds to leave room for the organization to balance velocity and stability, so you're not just slowing down your teams more than agreed and needed, so you have room to innovate. If you exceed too much your SLOs, it's very likely you're not innovating enough because you're not failing and you have no room to fail. So the balancing act is very critical. There you have it. Your service level indicators drive your service level objectives, which informs your service level agreement. By proactively defining the right indicators, you define the flexibility between agility, velocity, and uptime and stability. In our next segment, we'll cover how this is implemented and enforced thanks to risk and error budgets.